Hi class. So we'll continue with Unit 8 and now we'll look at the logarithm laws and then we'll use these in solving equations. Okay, so we're used to the exponential laws. These are ones we've seen throughout our previous math courses. So the key thing here for the first few here is that you have the same base, so x would be your base. So when you have the same base and you're multiplying and you have exponents, you add them. When you divide, you subtract. When you have a power on a power, it becomes a multiplication. Then a negative exponent is written as a positive exponent when you flip it around, a reciprocal. And anything to the power of 0 is 1. So let's look at the corresponding logarithm laws. So for the first one there, you see a product AB, so that can be separated as a sum of the individual A and B logarithms. A division then would just be the opposite. It would be written as a subtraction. A logarithm that has a value to a power, the power is written first. And then when you have a fractional logarithm, the base to the power, the power becomes negative, and then anything to the log of 1 is 0. Okay, so let's look at utilizing those. So just kind of like what we did when we had exponent laws. Okay, so what you want to do is look at your logarithm laws and figure out which ones are being utilized. And just like with exponential laws, we can do questions that have a combination of one or more of the laws. Okay, so here we got log 6 x over y, so that's a division. So the division then is just written as a subtraction. Okay. The next one here, you've got a product and a power, right? So it's remember it's a power because a square root is actually a power of 1/2. Okay, so there's our power, and so now it's a product, a multiplication of x, y, so we can separate that as a sum. Okay, so that separates it, and then now that 1/2 that we see, what happens? So this is using a different law, is that 1/2 goes in front. Okay. Okay, next one, we've got a division. So first thing I'll do is I'll bring that x up, so I can rewrite this as. Okay, so what you can see here is you still need to know the exponent laws as well. So 9, so I'm going to bring the x up. So if I bring the x up, it's at the power of 2/3 right now. Remember, 2 is the power and the 3 is the root. And so if I bring it up, it's going to be negative 2/3. Okay, and so this is written as so what's happening here, it might not look obvious, is you've got the 9 and the x are basically multiplying each other. So what we can do here is we can write this out as log 3 of 9, and then that's going to be subtracted because of the negative sign there of 2/3 log 3 of x. Now, because the log 3 of 9 doesn't have any variables, no letters there, you can evaluate that, and so that's just saying 3 to the x equals 9, so x is going to equal 2. So you can just write this as 2 minus 2/3 log 3 of x. Okay, and you can just leave it like that. Okay, and the last one there, so you got a bunch of things going on there. We got multiplication and division, and we got some powers. So this is going to equal log 7. So it's important that you always write in the subscript. Okay, that's basically defining what type of logarithm you have. Okay, so there's the multiplication. That's why those two are written as the sum. And then you got your dividing by z rooted, square root of z. So that's going to be minus log of z to the 1/2. And then we can write this as 5 log 7x plus log 7y minus 1/2 log 7 z. Okay. Okay, and now so here we were just working with variables. If we're working with numbers, we can evaluate using the logarithm and exponent laws. So this one here is going to be log 3 of 9 plus 1/2 log 3 of 3. So where I'm getting the 1/2 from, the 1/2 is the square root of 3. Okay, and then we can evaluate these separately. So this one, log 3 of 9 is going to be equal to 2. And then the 1/2, and then log 3 of 3 is just going to be 1. So this is just going to be equal to 5 over 2, or 2.5. Okay, next one here. You see how we have the subtraction. So there's a couple ways you can do this. You could go through each of those three separately, or if you want, you can combine these. So what you have here basically is the log of the fifth log here of 1,000. Okay, and then over 4 times 2. Okay, so what I've done here is the opposite. I've taken 3 separate logs and combined them. And so 1,000 divided by 8 is going to give you 125. And that's going to equal 3. So you would have got that if you took the 3 individually and worked them out, but it's less work if you kind of combine them. And then the final one here, you've got log 3 6 squared, so I'm just bringing out what's in front as an exponent, minus log 3 64, which is 1/2 is the square root, and then plus log 3 to the 2, which equals log 3 to the 36, right, the 6 squared, minus log 3 to 8, square root of 64, plus log 3 of 2. And then what you can do is, just like we did in the previous one, you can combine these. So this is going to equal log 3 of 36 times 2 divided by 8. Okay, so if you see what I did there, it's just like anything else that's addition, subtraction. You can move things around. So the 36 and the plus log 3 of 2. So because that's a sum, it's written as a multiplication. And then because you're subtracting the 8, that's why that comes down as a division. And so all of this is going to equal to log 3 of 9, which is going to equal 2. Okay, last one here. So now we're adding some brackets. Okay, so it doesn't matter, we still treat this the same way. This is going to be equal to log 3 x to the power of 4 minus, so that 1/2 that's in front of the brackets is just going to be distributed to everything within the brackets. So that's going to be minus log 3 x to the 1/2 plus log 3 x to the 5 over 2, which equals log 3 x to the power of 4, which is what's on top there. And then on the bottom there you've got x to the 1/2 and x to the 5/2, which is going to be 6 over 2, which is x cubed, because that's being subtracted. And so this is just going to be log 3 of x. Okay, and notice the question says to state the restrictions. So the restriction here is x has to be greater than 0. Okay, and the last one here. So this is kind of bringing back some of our factoring. So let's combine this first. So you got x squared minus 9 over x squared minus x minus 6. So if you look at the top there, that's the difference of squares. So it's x minus 3, x plus 3. And then if you look at the bottom, we can factor that out as x plus 2 and x minus 3. So what happens here is the x minus 3's cancel out. And so you're left with x plus 3 over x plus 2. Okay, and same thing, we want this to be greater than 0. So you have to have x has to be either x has to be greater than 3 and less than -2, right? So in order to get you values that are greater than 0. Okay, so let's look at some calculations now. So just kind of combining everything that we've looked at. These are equations that have logs in them. So one thing you notice here is the bases are all the same. And so what we can do for the first one here, and just like everything else that we do, we can move things to other sides of the equation. So if you look at what we're doing here is we're solving for x. Okay, so let's, just like we normally would, let's keep the x on one side, and let's move the log 7 to 4 on the other side, so it becomes a minus. Okay, and so now what we can do is we can combine the 12 and the 4. And so that 12 and 4, that's going to be, because it's a subtraction, that's written as 12 over 4. And so what you're doing here is you're canceling the log 7. Okay, so the log 7 is canceled there, and it's canceled there. And so your answer here is x equals 12 over 4, or x equals 3. Okay. let's look at the next one here. So this time we've got x's on both sides. So let's put them together. So we got log 2x minus 6. And we'll move that log 2x minus 4 on the left-hand side, so it becomes a positive. And so we'll just, that's all equal to 3. And so we can combine the, x minus 6 and x minus 4. So that's a sum. So that means it's going to be written as a multiplication. Okay. And so now what you have here is this is all equal to 3. Okay, so just like everything else that we've done, when there's something you want to get rid of, you need to have it on both sides. So we want to get rid of that log 2. And so the only way we can get rid of that log 2 is we have to put a log 2 on the right-hand side. Okay, so how do we put a log 2 on the right-hand side? Well, we have to have something that's written as log 2 that's equivalent to 3. Okay, and so what that's going to be is log 2 to the power, log 2 to 8, right? So if you think about that, log 2, and you can verify this on your calculator, log 2 to the 8 is equal to 3. So I've just written 3 a different way, and the reason why I've done this is because I want to get rid of the log 2. So now I've got x minus 6, x minus 4 equals 8. Okay, and so now I can solve that. So what I'm going to have to do is I'm going to have to multiply that all out and move the 8 to the other side. So after I do all that, that's going to give me x squared minus 10x plus 16 equals 0. And then I've got to factor that, and so I get x minus 2 and x minus 8 equal to 0. And so x equals 2 and x equals 8. Now, what you want to do is you want to verify this. Okay, so what you want to do is you want to put this into back in, and what you can notice, or hopefully you can notice right away, is the 2 isn't going to work, because if you look at the original question, if you go 2 minus 6, that gives you negative 4. If you go 2 minus 4, that gives you negative 2. And you can't have a negative in the logarithm. So this one is not, 2 is not going to work. So your only solution here is 8. Okay. And then the last one here. So this one, you see how we have it written to the 5th power. So we can bring that out front. And so we've got x squared minus 8x equal to 10. Okay, so same thing that we just finished doing for the previous one. What we want to do is we want to write something out that has a log 3 in it that's equal to 10. And that is going to be, or sorry, not 10. What we can do first is we can divide both sides by 5, so it becomes 2. So that makes it a little bit easier. Okay, so we divided both sides by 5. So we want to do something that gets rid of the 2 and makes it a log 3. Okay, so the equivalent. And so that's going to be log 3 of 9, right? Because 3 squared equals 9. Okay, so the log 3's go away on both sides. You get x squared minus 8x minus 9 equals 0. And you can factor that out, which is going to give you x plus 1 and x minus 9. And so you get x equals negative 1 and 9. Okay, and so make sure they both work, and this time they both do. Okay, finally, let's wrap up by going through something that we looked at before. But before, we had to kind of use a trial and error estimation type method to get the answer. And now we don't have to do that. Okay, so what we can do here is we can just basically use the log functions to give us a more precise answer. Okay. So the way we do this is we're going to use common logarithms. Okay, so that's your base 10. Okay, and so what we do is we take the log of both sides. So we take log of 2 to the power of x, which is equal to log of 2500. Okay, and so now so we're solving for x. So x is an exponent. So using your logarithm laws, that's going to go out in front. And so this is going to be x equal to log 2500 over log of 2. Okay, so what you have to do now, and I'm going to get you to do this on your own, you have to use your calculator. Okay, so you're just using the base function. Okay, so let's do this together. Okay, so use your calculator. And what you want to do is you want to take the log. This is the regular one. Now on your calculator, it might have a 10 at the bottom. That's the same thing as a common logarithm. Okay, so what you do is you take 2500, take the log of that, and then divide it by the logarithm of 2, and you should get an answer of 11.29. Okay, so that's rounded to 2 decimals. Okay, and then what you can do now is you can verify that answer by taking 2 and putting it to the power of 11.29, and it should give you roughly 2500. Okay, so this is the method that we use to get sort of an answer without having to go through that estimation process. Okay, let's try another one. Remember, before what we were doing is we're trying to get a common base, so this one wouldn't allow us to do that. Okay, so same thing here. We take the common logarithm of both sides. Okay, so we take the log of both sides, and then x minus 5 is a power, so that goes in front. Okay, and so now what we do is we leave the x minus 5 on the left-hand side, and then we've got log of 1700 over log of 5. And so to solve for x, then x is going to equal, oh sorry, it was x minus, I wrote it down wrong. It's x minus 3, not x minus 5. So x is going to equal to log 1700 divided by log of 5 plus 3. Okay, so again, work that out on your calculator. So so use the use the log function. Okay, so 1700, take the log of that, and then divide it by the log the log of 5, and then add 3 to it. Okay, so that gives you 7.62. Okay, and the last one here, a little bit different. Okay, so we've got same. So you notice I'm doing the same thing for each question. So we're taking the log of both sides. Okay, and then take the exponents and put them in the front. Okay, so that's using the logarithm rules. Okay, and so now what we do, what we're going to do a little bit differently here is we'll use a distributive property. So 3x plus 1 will go 3x log 6 plus 1 log 6 is equal to x log of 8 plus 3 log of 8. Okay, and so remember we're solving for x, right? So let's put the things that contain x on one side. So we got 3x log 6 minus x log of 8 equal to 3 log of 8 minus log of 6. Okay, so what you see here is we got x on both of these, so we can factor out the x. Okay, and now we can move everything over to one side. So the 3 log of 8 minus the log of 6. So what that's going to be, so that's a subtraction. So that's going to be or actually we can leave it like that if you want. So we can just go 3 log so we can leave it like that, or we can combine these. Actually, let's just try to shorten this down a bit. So we'll write it as the log of 8 cubed divided by 6, and then that's going to be over the log of 6 cubed over 8. Okay, so 8 cubed over 6 divided by 6. So that's going to be the log of 85.33 repeated over 6 cubed divided by 8, which is log of 27. And so this is going to be 85.3 repeated log divided by 27 log, and so that'll give you 1.35. Okay, and then you're done. Okay, and just like everything else we've ever done solving equations, you can put this back in and you can test to see that it works. Okay, so put it back into the original question. All right, so I'll stop there. Now you can work on the corresponding questions.